Okay, the sinusoidal test. Sinusoidal. So, given y equals a sine bx plus c plus d. So I'm going to give you one of those with numbers, right? Actual real life numbers. And you will have to identify the value of d, midline, median, the amplitude, calculate the period, and the horizontal shift and the range. Okay, so you got to be able to do all of those. I'm going to give you these formulas, right? They're on the sideboard there. So you'll have a formula for horizontal shift. It's really just plugging in the numbers. So a nice few easy marks, right? I mean, really. Amplitude and midline are trivial. It's really just saying what number is in what place. Period requires a calculation, as does horizontal shift, and as does range. Identify periodic graph. This graph is sinusoidal. This graph is not sinusoidal. That was like the third bell. So a sinusoidal graph is a wave, and a non-sinusoidal graph is, that's like a sawtooth graph. And actually, does anybody have any of those inverters you plug into your car, like cigarette lighter, that'll put out voltage? They put out a wave that looks like this. It's not sinusoidal, but it's good enough to power your computer or to charge up your phone or something like that. So we're interested in being able to identify, is a graph periodic? So a non-periodic graph would be, so this is not periodic, right? Periodic graph has to repeat. So you need to be able to identify, is a graph sinusoidal or not, and what its period is. Okay, so determine the period. Wow, state the period, really. State the period. Given a range, be able to calculate the amplitude. Be able to find maxes and mins. Be able to find midlines or medians, right? Also sometimes called the median. Use an equation to find y given x and x given y. And watch for rounding, right? I mean, round correctly, especially on numerical response, right? All this is before, so I mean you'll be able to watch this later tonight or on the weekend if you want to. Don't want to drag it out too long. Do a regression. You don't need to copy it, just watch it later. And when you do regression, pay attention to rounding, because I will. Okay, if it asks you to round to 3 decimal places, round it to 3. 2 decimals, round it to 2. If your rounding sucks, go into mode and set your calculator to the number of decimal places you're supposed to round to, and your equation will come out rounded to that value. If I ask you for a regression equation, if you give me this, no imagination, I will give you 0. Okay? I'm saying it right now, here, publicly. So when you watch, will you give me 0 in that? Okay, because that's what you did. Okay, when I ask for a regression equation, I expect it in this form. Except all on one line. I'll give you space to squeeze it in on one line, right? That's how you write it. You write it down as the calculator gives it to you, you will get nothing. So it's up to you and the 2 marks, which you want or don't want. Given an equation in context, so that could be the hours of daylight. Just think back to the hours of daylight one, right? Like give you the equation for hours of daylight. I think we did Montreal or something. Give me an equation and a context. Then I'm going to ask for stuff like what's the average number of hours of daylight, or what is the D value in the context of this situation. Okay? So given an equation and a context, be able to either identify, if I ask you for the average number of hours of daylight, be able to pull off the correct number. If I ask you for the minimum hours of daylight, maximum hours, etc., use units. Okay, you got to give units. So you should be able to figure out period, midline, amplitude, max and min. Use units. No units, half mark off every single time. So you want to lose 3 marks on the test, just don't put any units in. Good way to lose 3 marks. Okay? So if there's a context, it has to have units. So let's just say this is day of the year. Let's just use that. Let's say this is time, and this is height. So let's say we got the old Ferris wheel question, right? We got a time, and let's say this time is in seconds, and a height. Then the time that's in seconds, that affects the B and the C parameter, right? They'll both be measured in seconds. The period will be in seconds, okay? And the period will then be used to calculate the B value if necessary. If I give you the B value, then you'll calculate the period, and you'll express it with seconds. If there's a horizontal shift, then you'll say you first reach the midline at so many seconds, right? You'll identify the x-coordinate at that point and say that the height of the car or the person or whatever at this time, at 20 seconds, is when it first reached the midline. Height. This deals with A and D. So if I ask you what's the height of the hub of the Ferris wheel, you'll know that's the D value, and you'll say so many meters or feet, whatever it's in. If I ask you what the radius is, or if I ask you what the amplitude is, you'll say it's the radius, or the radius of the wheel is so many feet, meters, yards, whatever it's in. So make sure you use units. Make sure that you understand the context of those various situations. What else? Be able to draw a graph. So draw a graph. Given some info. Such as midline, amplitude, period. Or maybe I give you the D value, the A value, and the B value. Those guys are the same, right? Midline is D, amplitude is A. These guys are not the same. You know, you have to use the formula or its variation to calculate one or the other. Okay? You're only getting the one formula. Period equals 2 pi over b. Okay, so if you need to calculate b, you need to rearrange the formula or just say, yeah, okay, I've done a bunch of those. I know that b is 2 pi over the period. And draw me a graph. I'm not going to give you a c value. I'll just say draw a graph. You can draw it shifted any way you want or not shifted at all. You know, I won't really care. Okay, what I just want to see is that you've got the correct period, that you've got the correct amplitude, that you've got the correct midline. Right, then I should be able to pull all that off. Again, context and units. So given a graph, like on the review sheet, characteristics, and parameters. Okay, just check the answers at the back. Characteristic is that the amplitude is 2, the parameter is that A is 2. A equals 2, right? So if the characteristic is, I think we start with midline actually. So if the characteristic is that the midline is y equals 4, the parameter is d equals 4. Okay, so midline, you really should be giving the equation. You should be saying y equals 4. And then for the parameter, you say d equals 4. If the amplitude, I ask you for the amplitude, you just state the number. So if the amplitude is 3, then you say a equals 3. This is the characteristic, right? Just count it off the graph or observe it from the graph. The characteristic is observed from the graph. Here's the midline. It's the line y equals 4, which means the parameter is d equals 4. The amplitude is 3. How'd you get? I just counted, right? I'm not going to ask you to calculate it. And the parameter is a equals 3. The period is pi. Remember, a little bit over 3 is pi, a little bit over 6 is 2 pi. Period is pi. The b value is 2. Okay, so they differ, right? I mean, that's where there's a difference. Is that A and D, you know, they are the numbers. B is not the period, and the period is not B, but can be used to calculate it. And lastly, the horizontal shift. If the horizontal actually, we could describe this differently, right? Whoops. Shift the whole thing. Bring that back. So if we said 2 units right or something, I would also take just a 2. Okay, I don't expect, you know, a whole bunch. Just so you identify and say the horizontal shift is 2. You know where to find that, right? You draw in the midline and you look for the first up swoop, and that's your horizontal shift. That's negative c over b. Since you already know b, you can then calculate c, right? I mean, that's going to take some work, which I don't care about, right? I just want to see c, but the work that you would show would be, okay, negative c over b is equal to 2. Negative c is 2b. C is negative 2b. C is negative 2 times 2, so c is negative 4. Right? And then you go write that up there. I just made all those numbers up, right? So where did they come from? I made it up, right? But pretending we got that information from a graph, characteristics are on the left and the parameters are on the right. Okay, and that's how you're going to state them. Okay, so just like the review sheet, right? Just go look back there, and that's what we're looking at. There's 2 of those that are worth like 8 marks. 8 marks. Okay? Last one. Given a situation and a partial table. So let's say it was like the tire, right? The tire with the nail, that kind of thing. So with the tire, I think I gave you the whole table, right? I gave you a whole table of values. Let's say I just described the situation. A tire picks up a nail. It doesn't go flat. There's no air leaking, right? So that we know it's not decreasing in size. And it did that at time 0, picked it up on the ground. And at this time, it was at 14. And this time, it's moving at a constant speed. And when 0, 14, 28, 56, 70, then I would expect you to be able to fill in the rest of that table, right? It's going 56. Because you know that it's going up and it's going down, right? And we're describing that. And remember, a sinusoidal graph is split into 4 parts. Where did everybody show up today? Almost. Missing 2, 3. But show up on Monday, please. It'd be nice to. And this test should boost your mark, right? I mean, really, you know. This should be a fairly well done test, and it will be on your report card because I'll mark it Monday night. I gotta have your marks in Tuesday. So if you don't write it Monday and I don't see excused, I'm gonna put a 0 in there, and that's the mark that's gonna go on your report card. Okay? So if it's an unexcused absence on Monday, no phone calls, not excused on my computer, you're getting a 0. That might get changed later, but you'll be given a 0. That will go on your report card. That's the one the universities will see if you start sending stuff. So show up. Given a situation, a partial table of values. Complete the table. Sketch the graph. Remember, sinusoidal graphs in 4 parts, right? From the midline to the max, from the max to the midline, from the midline to the min, and from the minimum back to the midline. And you could start anywhere. Maybe they start at the midline, maybe it starts at the minimum, maybe it starts at the maximum, but you know what it does from each part. So just, you know, be aware of what's going on. Sketch the graph. Determine an equation. Actually, I'm not sure if it's determine or state the equation. And you can do that from the graph. Remember the graph we did the other day? Because I don't, but remember what graph was that? That was a temperature graph. Remember the temperature graph we did there? And we were within tenths on each of our parameters from the regression equation. Okay? So I'm basically going to give you a pretty perfect situation, right? It's just going to map directly to a sinusoidal. So determine, state the equation, right? So you're going to kind of fill in the rest, figure out what's going on there. So think about the situation, fill in the rest of the table. You know it's sinusoidal, you know that the pattern is going to kind of do this. So fill in the rest of the table, think about the situation, what's going on there. Sketch it out reasonably. Use your max and your min to get D. Use your max and your min to get A. Get the period from the context, right? I mean, you know, it'll complete one rotation. If it's the tire, it'll complete a rotation in 1 second or whatever. Use that period to get the B value. State it as a fraction of pi, right? Just 2 pi over 12 becomes pi over 6. And then if there's any horizontal shift, you can use that to get the C value. Once you've got that equation, then there's going to be a couple of questions asked about that, right? Like at what time is the height of the object this, and if the height of the object, when does the object first reach this height? You know, like when does the nail first reach 32 centimeters or something, right? You'll plug that in as y1 and y2 in your calculator. That's about it. That's worth 8 marks as well, right? Like 2 for each. Okay, so like I'm not sure if filling in the table is 2, I think, but filling in the table and completing sketching the graph. I'll tell you what the situation is. I'm going to give it away. So what it is there's a mass hanging from a spring. Okay, so imagine that there's a mass hanging from a spring. Okay, and I pull it down. What's going to happen? Up, down, up, down, right? Somewhere there's going to be a midline. The midline is really just going to be its resting position, right? And I'm going to pull it down, and it's going to go up, down, up, down. It's going to do that periodically. It's going to damp out eventually, right? But we're dealing with sort of the perfect, there's no friction and anything, so it's just going to keep doing that forever, or at least the few cycles that we've got going on. So think about that situation. What would happen if I had a mass, I pulled it down and let it go, and it does this? Just think about the heights that it goes through over time. Okay, and that's the situation that you're going to get and have to analyze. That's it. Okay, that's all there is. Any questions? Any questions? No? Good. Finish.